Hello friends, welcome to my YouTube channel Learn with Engineer. Today we will discuss about long line model of transmission line part second. In first part that is covered in my previous video, we have derived the equation for voltage and current in terms of distance x from receiving end. In previous video we have seen voltage and current are changing at each and every point of the transmission line because all the parameters that is resistance, reactance, capacitance and leakage are distributed along the whole transmission line. So this is also called distributed parameter model. So we have derived two equations in the previous video as here. This is equation 1 and this is equation 2. Now here gamma is the propagation constant and C1 and C2 are the constant whose value we have also derived in my previous video, that it will be 1 by 2 VR plus Z naught IR. C2 is equal to 1 by 2 1 by R minus Z0 IR. This is equation 3rd and this is equation 4th. In my previous video we have derived these equations. So if you want to learn from where these equation we have got, please refer our previous video. So we move further we proceed our discussion with from here. Now x is distance from, this is sending end and this is receiving end of transmission line, and here x is equal to 0 at receiving end and x is equal to L at sending end. So from here at a point of x, here at a distance of x, we have got the equation for voltage and current in terms of x and constants gamma and C1 and C2, where gamma is the propagation constant as we have discussed earlier. So we move further. Now concentrate on equation first. Now concentrate on our equation first. This can be written as V is equal to C1 e की power gamma x plus this is already written, V is equal to V1 plus V2. This is V1 and this is V2. V1 can be written as C1 e की power gamma x. Now concentrate on this C1 e की power gamma x, as we know that gamma can be written as value of gamma is under root y into z, where y is the shunt admittance of the line per unit length and z is the series impedance of line per unit length. So this can be written as y can be written as g plus j omega c, and this z can be written as r plus j omega l. G is the leakage of the line per unit length, c is the capacitance of the line per unit length, r is the resistance of the line per unit length, and l is the inductance of the line per unit length. So this term is a complex number and this is also a complex number. So obviously the solution of this equation, that is value of gamma, will also be a complex number, which can be written as alpha plus j beta. Gamma can be written as alpha plus j beta. So put the equation, put the value of gamma from here to equation of v1. c1 e की power alpha plus j beta into x. Clear? Now this can be written as c1 e की power alpha x into e की power j beta x. Now it is in a polar form, so magnitude of v1 will be as c1 e की power alpha x and angle of v1 will be beta x. So magnitude of v1 is equal to c1 e की power alpha x and angle of phase of v1 is beta x. Now again, what is x? X is the distance from receiving end. Now if x increases, that is line, this is line vs vr, sending and receiving end, x is equal to 0 and x is equal to L, this here. When x increasing, v1 also increasing. That means if we plot the graph for this magnitude of v1, suppose this is sending end and this is receiving end. Here x is equal to 0 and here x is equal to n, where L is the length of line. Okay, and this is, here we plot the magnitude of v1 as x increases, that is if we move from here to sending end, from receiving end to sending end, v1 also increases exponentially. So the curve will be as here. So what? This. So the magnitude, so the magnitude of v1 is changing with the change in the distance x. If we see this, it is behaving, v1 is behaving like a wave. v1 is behaving like a wave. What is wave? Wave means in which magnitude and phase is changing at every point of medium. We know that. What is wave? Wave means in which magnitude and phase is changing at each and every point. Here also the magnitude of v1 is changing from at every point, and also the with the change in x, phase of v1 changing. Somewhat this suppose this is 10 volt, this is 11 this is 11 volt, this is 13 volt, this is 14 volt, some like this. Here suppose that angle is, here angle is 0 degree, here angle is 1 degree, here angle is 3 degree, that means here angle is 5 degree. This is rough data, but we see that the volt magnitude of v1 and phase of V1 is also changing. So it is behaving like a wave. So now if wave propagates through a medium, that is moves through a medium, that means propagates through a medium, then there will be the loss of energy. There will be the loss of energy, due to which the amplitude of wave is decreasing in the direction of propagation. Clear? When wave propagates through a medium, there will be loss of energy, and due to which there is the decrement in the value of magnitude, in magnitude. So there is a decrement of magnitude in the direction of propagation of wave. Here V1, value of magnitude of V1 is decreasing from sending end to receiving end. So the direction of this wave will be from sending end to receiving end. This is sending end, this is receiving end. Clear? As magnitude of V1 is decreasing from sending end to receiving end, so the direction of this voltage wave will from sending end to receiving end, and also energy is flowing from sending end to receiving end. So this is called forward traveling wave. Forward traveling wave, or something called incident wave. Incident wave. So this component of V, that is V1, will behave like a wave, and this is called forward traveling wave of incident wave. Now clear? This is a physical interpretation of this voltage. Now again, if it is clear, okay. Now again, since alpha, here according to alpha, magnitude of V1 is decreasing, so alpha is called attenuation constant. Attenuation constant. Here amplitude of magnitude of V1 is decreasing, increasing according to alpha, or alpha is so alpha is called attenuation constant. Attenuation means by the factor which will decrease the magnitude. And here this, since here phase of V1 is changing according to beta, so beta is called the phase constant. Phase constant. Beta is called phase constant, and alpha is called attenuation constant. Now again, since gamma is equal to alpha plus j beta, alpha is attenuation constant, beta is phase constant. So since V1 is V, voltage V is acting like a wave, so gamma is called the, and it is propagating, so gamma is called propagation constant. So it is the practical importance of these constants alpha, beta and gamma. Now again, one thing, unit of angle is radian, and unit of x is meter or kilometer. So unit of beta will be in radian per kilometer or degree per kilometer. So unit will be the radian per kilometer. Okay, this is in radian per kilometer. So it is all about alpha, beta, gamma, and unit of beta. Now one thing is that if it is acting like a wave, so it will have some wavelength. So what is the wavelength? Wavelength is the distance corresponding to which wave returns to its original, that is initial phase, that is called wavelength. Means कोई वेव अगर प्रोपेगेट कर रही है तो किसी डिस्टेंस, वो डिस्टेंस जहां पे जब वो वेव शुरू हुई थी, सपोज दैट यहां पे शुरू हुई थी और यहां तक जा रही है, सपोज दैट यहां पे शुरू हुई थी, ये 0 डिग्री पे थी, तो जब ये अपने सेम फेज में जितनी डिस्टेंस के बाद आएगी, सपोज दैट दिस इज x, x is already taken, so suppose that it is something d. आफ्टर d डिस्टेंस के बाद अगर ये वेव दोबारा से अपने फेज में आती है, दैट मीन्स 360 डिग्री और मल्टीपल, देन दिस मिनिमम लेंथ, that is for 360 degree d will be the wavelength, that is represented by lambda. Now suppose beta, let beta is 0.09 degree per kilometer. Let beta is 0.09 degree per kilometer, as beta unit of beta is radian per kilometer, 0.09 degree per kilometer. So if we take receiving end as a reference here, 0 degree, after 1 kilometer, the angle will be the 0.09 degree. After 1000 kilometer, the angle will be the 90 degree, and after 4000 kilometer, the angle will be 360 degree. So the phase of the wave will be equal to 360 degree at a distance of 4000 kilometer. This distance is called 360. This distance is called wavelength. Lambda. It's called lambda. Wavelength lambda. So clear? Distance corresponding to 360 degree is called 360 degree of phase is called wavelength. So from here, wavelength lambda will be equal to 2 pi by beta, as we see that 4000 is equal to 360.09, LHS is equal to RHS. So this is lambda, this is 2 pi, and this is beta. So wavelength lambda is equal to 2 pi by beta. This is the formula for the wavelength of this wave. Now again, what will be the velocity of wave. Velocity of wave Vc. Vc, velocity of wave will be as lambda by f. This is velocity of wave, lambda by f. Now, this is all about the physical interpretation of alpha, beta, gamma, wavelength lambda, and voltage voltage V. One thing is remaining, that other component V2. Other component of V is V2. Now consider at this part of V2 V. Here V2 is C2 e की power minus gamma x. So this can be written as C2 e की power minus alpha x into e की power minus j beta x. So magnitude of V2 will be C2 e की power minus alpha x, and angle of V2 will be the minus beta x. So here, as x increasing, V2 is decreasing. So if we plot the curve as plot previously, this is x is equal to 0, x is equal to L, L is equal to length. Okay, so as x increasing, V2 decreasing. So here the curve will be as this, and this is sending end, and this is receiving end. Since here the magnitude of V2 is decreasing from receiving end to sending end, so the direction of propagation will be as from receiving end to sending end, and it is opposite to the energy flow, that is from sending end to receiving end. So it is called backward traveling wave. Backward traveling wave, or called reflected wave. Reflected wave. This is all about component of V2. So this is all about the physical interpretation of V and constants alpha, beta, gamma here. Now we will find what will be the ABCD constants of a long line model. So previously in my previous video, we have find the equation for voltage and current as here. This is voltage and this is current C. Current 1 by Z0 C1 e की power gamma x minus C2 e की power minus gamma x, and our value of constant C1 is 1 by 2 VR plus Z0 IR, and value of C2 is 1 by 2 VR minus Z0 IR, where Z0 is the characteristic impedance. Z0 is characteristic impedance or surge impedance, and this will be used in protection system, which we will consider, which we will discuss in our further videos. So put the value of C1 and C2. in equation first. Put the value of C1 and C2 in equation 1. V is equal to 1 by 2 VR plus Z0 IR into e की पावर गामा x प्लस C2 की वैल्यू रही यहाँ पे 1 by 2 VR माइनस Z0 IR into e की पावर माइनस गामा x. So here VR will be as e की पावर गामा x प्लस e की पावर माइनस गामा x by 2 and Z0 IR is equal to e की पावर गामा x minus e की पावर minus gamma x by 2. So this could be written as cos hyperbolic gamma x and this could be written as sin hyperbolic gamma x. So V is equal to VR cos hyperbolic gamma x into VR plus Z0 sin hyperbolic gamma x into IR. So this is the voltage at any distance x from the receiving end. At x is equal to at sending end, that is at x is equal to L, V is equal to Vs and I is equal to Is. So put the value of here Vs will be as cos hyperbolic gamma L into VR plus Z0 sin hyperbolic gamma L into IR. Suppose this is question 5. Sending end voltage in terms of receiving end voltage and receiving end current. Now again concentrate on the equation for current. I is equal to 1 by Z0 C1 e की पावर गामा x minus C2 e की पावर minus gamma x. So put the value of C1 and C2. 1 by Z0 and value of C1 will be C1 is 1 by 2 VR plus Z0 IR into e की पावर gamma x minus C2 is 1 by 2 VR minus Z0 IR into e की power minus gamma x. So this can be written as or here 1 by Z0 VR is equal to VR in e की gamma power VR equal gamma x minus e की power minus gamma x by 2 plus z naught IR e की पावर गामा x minus and then minus plus, and this gamma x by 2. This is sine hyperbolic gamma x, so this can be written as VR by z0 sine hyperbolic gamma x plus z0 से z0 कैसे ले जाएगा, तो IR cos hyperbolic gamma x, cos hyperbolic gamma x. Okay, again at x is equal to L, I is equal to IS. So IS is equal to sine hyperbolic gamma L by z0 into VR plus cos hyperbolic gamma L into IR. So this is the equation for sending end current in terms of receiving end voltage and receiving end current. Now compare these two equations. Suppose that 5. Now compare these two equations with equations of generalized with generalized equation of ABCD constant of transmission line B IR, and this is 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 equal to C VR plus D IR. VS from here, A is equal to cos hyperbolic gamma L and B is equal to Z0 sin hyperbolic gamma L, Z0 sin hyperbolic gamma L, and from these two equations we get C is equal to 1 by Z0 sin hyperbolic gamma L plus sin hyperbolic gamma L, and D is equal to cos hyperbolic gamma L. So these are the values of constant A, B, C and D model. ABCD is A, B, C and D parameter for long line model or distributed parameter model of transmission line. So friends, in this video this is all about the long line distributed model of transmission line. So thank you very much.